All right, in this lesson, we're going to start looking at the inverses of exponential functions. So we're actually going to start with the warm-up. So I'm going to go ahead and zoom in on number 1 here. It says to find the inverse of that function. We've got the f of x function. So what I want to do is find x. So right there's x. And I want to find y. And I know it sounds weird, but remember f of x is the notation, it's the function notation for y. And I want to reverse those two variables. So wherever I have an x, replace it with a y. Wherever I have a y, replace it with an x. So this first step is going to be x equals, now I'm going to do the cube root of y plus 9 minus 4. So where I had a y, I replaced it with x. Where I had an x, I replaced it with y. Now I want to resolve this thing for y. All right, and there's a bunch of different ways to know how to do this. Basically, you're doing the order of operations backwards. So whatever would have happened to y, we want to undo it in the reverse. So my first step is going to be to add 4. So get rid of that. I'm going to have x plus 4. Those are not like terms, so I can't combine them. So now I've got the cube root of y plus 9. And if I look, y is still not by itself. So I'm going to keep going. My next step here, I want to get rid of that cube root. So I'm going to go ahead and cube both sides. Cube and cube root cancel. So I've got y plus 9 on the right side. On the left side, please do not multiply out x plus 4 cubed. I don't want to know what that is. I just want to leave it as x plus 4 cubed. Okay. Y is still not by itself, right? It's sitting right there, but it still is attached to a 9. So let's go ahead and unattach that 9. And you're going to have x plus 4 cubed minus 9 equals. Now, there's two ways to do this. You can either just put down y, or you can do the inverse function. I'm going to go ahead and use inverse function and not the inverse function notation, or not the inverse of x function notation, because I'm not sure that this was a function to start with. So to have it be a function now, I'm not sure. But I can tell you that this is the answer. All right, so that's problem number 1. I'm going to slide over to problem number 2. And this is kind of like what we were doing with those exponential growth and decay functions. It says use the function g of x equals 4 to the x to fill the table of values below. And so that means I am going to take 4 to the negative 2, 4 to the negative 1, 4 to the 0, 4 to the first, 4 to the second, and 4 to the third. And I want to fill in all those values. I'm actually going to start about halfway down the table. I'm going to start with 0. 4 to the 0 is 1. 4 to the first is 4. 4 squared is 16. 4 cubed is 64. Now, working my way back up at the top here, I want to be careful, and we've talked a little bit about this, but that negative power, the negative in front of the 1, means I've got to create a reciprocal. So for 4, the reciprocal of 4 is 1/4. And I'm going to do 1/4 to the first, which is just 1/4. I'm not going to go ahead and turn it into a decimal, just leave it as is. And then I can do the same thing here. The negative becomes 1/4, and then I want to do 1/4 squared, which means I need to take 1/4 times 1/4, which would be 1/16. Now, one thing that you might notice if you work with these long enough is 4 to the first is 4 to the first is 4. 4 to the negative 1 is 1/4, so 1/4. 4 squared is 16. 4 to the negative 2 is 1/16. So if we needed to go further into the negatives, 4 to the negative third, 4 to the negative 3, will be 1/64. So they mirror each other a little bit, but they are reciprocals to each other. Okay, so that's problem number 2. I'm going to slide over to number 3, but I want to still keep number 2 on the screen. So we use this function to fill in the table of values. All right. Use the table of values from question 2 to fill in the table of values for the inverse function, right? G inverse of x. Now, you might look at this and say, well, how am I supposed to know what to do there? Well, remember in the problem number 1 we did it. When we look at inverses, what we want to take is the x values and the y values and swap them. So where this function has the point negative 2 1/16, I'm going to flip that here. So this would be 1/16 negative 2. And I'm going to keep doing that for the entire list. So 1/4 negative 1. Instead of this 0.01, now I'm going to have a 0.10. 64.1, 16.2, and 64.3. All right. So that's the big idea of how you find an inverse. You could either algebraically deal with an equation, which can work kind of nicely, or problem number 2 might not be that easy to figure out. So if we looked at trying to do it algebraically, but we can do it graphically and with this table of values. All right, so that's all the warm-ups. I'm going to go ahead and slide down. So this middle section here, there's really nothing for you to do. All right, I just want to talk through a couple of things. So first thing, we've got the function f of x equals 2 to the x. On this side, we have the table of values. So here's all of our x values. Here's 2 to the x, right? All of these values. And these points all got turned into this blue curve here. It's even labeled f of x. Now the inverse, we took this table of values and switched the x's and y's to create this table of values. So x and the inverse of x. When we graph it, it becomes this red curve right here with the function name f inverse of x. All right, so that's the big idea. What we want to do now is identify a bunch of key characteristics. All right, so f of x, right, this blue curve, we've done this characteristic search before. This is a growth function, exponential growth function. So domain, negative infinity to infinity. Range, 0 to infinity. Asymptotes, only 1, y equals 0. X-intercept, none. Y-intercept is 0, 1. Interval of increase or decrease. This is an increasing interval. It's actually an increasing function across the entirety of the domain. Okay. And end behavior, and I'm going to see if I can fit this in here. So as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches 0. Okay, so that is the basic function exponential. It's 2 to the x. All right. Now what I want to do is look at all of the key characteristics for the inverse function. This is where it gets kind of interesting. You can graphically look at it, but there are some pieces I want you to recognize. First thing, domain and range are going to switch places. So this domain for the function becomes the range of the inverse. The range of the function becomes the domain of the inverse. So if we look at the graph, right, this red curve is the function we're looking at. What are our possible x values? Well, it never goes negative. And while it kind of looks like it touches the x or the y-axis here, it actually doesn't. It approaches it. So this is going to be from 0 to infinity. Range-wise, how low? Negative infinity. How high? Positive infinity. So yeah, that makes sense, right? We just switched those two. Now the asymptote, instead of it being y equals 0, we're going to switch the variable, and the asymptote for the inverse function is x equals 0. So I'm going to zoom in on the graph just for that temporarily. So I'll do it and even color code it. So the blue curve right here has this horizontal asymptote, y equals 0. The red curve has this vertical asymptote, y equals 0. All right, so the variables switch places. So x becomes y, y becomes x. Now, the fun part is that's also going to be true for your x and y intercepts. So you don't have a y-intercept, right? This x-intercept, if we switch it, means that we don't have a y-intercept. And this y-intercept, we want to reverse the ordered pair, and it becomes the point 1, 0. All right. Now, this piece right here, right, this curve is still an increasing curve, but we want to be careful because it's increasing over its domain. So increasing, and that's domains from 0 to infinity. Okay. And the last piece we want to fill in is the possible, or I'm not saying possible, what are the end behaviors? So we want to be careful here because there's one thing that's going to happen that's kind of weird. So as x approaches infinity, f inverse of x approaches infinity. Now, you might want to look at this and go, wait a minute, that isn't, like, if you look at this, it's slow growth, but this graph is still increasing, all right? It's just going to take a really long time to increase a lot. So it's still increasing, but it's going up to infinity. Now, this is where it gets kind of weird, all right? Because when we talk about the end behavior, we want to talk about what happens as x approaches, well, x doesn't approach negative infinity because it never crosses this asymptote. So what we do talk about is x approaches 0 from the right side, which basically it's going to be some weird notation, but as x approaches 0 from the positive side is to the right, f inverse of x approaches negative infinity. And I just realized I put a parentheses where I don't need one. All right, so that is all the key features for f of x and inverse f of x, or f of inverse x, however you want to pronounce it. I will pop up another video when we start talking about some more parts of this note sheet. Let me know if you have any questions or concerns about anything dealing with the exponential function and its inverse.